Okay, here are the answers for the Solving Inequalities review for Monday's formative assessment. If you just want the answers, fast forward and don't listen to me. I'm just going to be pointing out some things like if it is a less than or a greater than, it's going to be an open circle. But if it includes a number, so less than or equal to or greater than or equal to, it is going to be a closed circle. The other thing I want to point out with this first section is question 3. Two things going on here. One, it's not written in the order that we like it. Most of us like to have the X on the left-hand side because we can see what it says. Here, it's not, so I've first reversed it. Notice that the open side goes to the opposite of X here, so when I reversed it, the inequality still opened to the opposite of X. Then I multiplied by -1. I didn't show that, but that's what I did to change the opposite of X to a positive X. Because I multiplied by a -1, I needed to switch the inequality symbol. So now I can see that X is all numbers less than a -8. When you are solving inequalities, it's just like equations, so I'm not going to spend a whole lot of time just pointing out a couple things. Remember, if it's divided, you have to multiply on both sides. If you're multiplying or dividing by a negative number, you have to switch the inequality symbol. Here I was multiplying, but it was a positive number, so I did not switch the inequality symbol. Here I was dividing, but not by a negative number, so I did not switch the inequality symbol. A common mistake I see with both 8 and 9 is ignoring this minus or acting like that it was a part of the 8. Really remember it goes with the 3x. I could have changed it to, instead of minus, plus a negative, so that way I can see that it goes with the -3. That also reminds me that I have to subtract the 8, not add the 8 to get rid of 8. 8 plus 8 would have been 16. It wouldn't have gotten to 0. So 8 minus 8. So that's a common mistake. One thing I'm seeing many of you do is your integers rules wrong. -7 minus 8 is not a -1. It's almost like you miss that negative sign. -7 minus 8 is a -15. So don't drop negatives. Because we were dividing by a -3 to get rid of it, we needed to switch the inequality symbol. Again, make sure you remember your integer rules. 9 was the exact same way, but this time it was a -8 out in front, so we had to add 8 to get rid of it. The negative still went with the 3x term. We were still dividing by a -3, so we still had to switch the signs. For 10, we added a little bit more complexity because we needed to use the distributive property. I'm still seeing a couple of you forgetting to distribute the multiplication to that second term. It's like you're dancing with both of these in here. So the 4 needed to dance with the x and with the 2. Don't drop your negative right here. So -5x minus 10. There are variables on both sides. The -5x was less than the 4x, so I added 5x to both sides and solved from there. This is the final answer. And same thing with 11. I think many of you were overthinking 12 and 13. Hannah is 16 years old. If she's the oldest, write an inequality. I think you guys are getting caught up with this whole having to write an inequality. Tell me what you know. If Hannah is the oldest and she's 16, that means the other two girls are less than 16 years old. They can't be 16, she's the oldest, so it's not going to be an or equal to. So their ages had to be less than 16. For 13, if the 7th graders ended with $277 and the 8th graders won, meaning they had more than that, couldn't have exactly 277 or it would have been a tie. So their amount of money is greater than 277. I did not define my variable here because it was done for me, so I did not do a let statement. 14 is a little bit more complicated application problem, and I actually forgot to copy and paste one of the questions that was the second part of this one, so I'll talk about the whole thing. First, I have a let statement. Let R be the number of rides. It tells us to use R, so I'm using R. If you use X, I'm okay with that. So you go to the fair with $20. The ticket is $5 and the rides are $2. The first thing I know is that what you spend has to be less than or equal to what you have. You could spend exactly $20, but you couldn't spend $21 because you don't have it. So that's the first part of what I'm looking for. So after that, it's just like writing an equation. We start with $5 up front, that's what we pay, and then we pay $2 for each ride. So 5 plus 2x has to be less than or equal to 20. What we spend has to be less than what we have. Now, I really meant for this to be a question, how many rides could you ride? How many could you go on? So if I'm asking how many, that's kind of open-ended. At most, I could only have 7 rides. So once I solved the inequality, I came up with x is less than or equal to 7.5. So at most, I could go on 7 rides. If the question asked for the maximum number, he would just say 7 rides. So 1 is a definite, how many could you go on? For the maximum amount, I would say 7. If it just says how many could I go on, I could go on 6 or 5 or 4, so at most 7 rides. That leads us to compound inequality. I'm completely fine with the and type of compound inequality. If you leave it as a compound, like leave it as one smushed together and show what you're doing in all 3 parts, like this one. If you wanted to write it separate, 5 is less than x plus 8, and x plus 8 is less than 25, and solve both of those and then smush it back together at the end, that's okay with me. This just seems like what most of you are doing and a little bit less work. So 15 was an and, 16 was an and, but I had to divide by -4. Because I divided by a -4, I had to switch the inequality symbols. And once I did, it wasn't in numerical order anymore. This is technically a true statement. -3 is greater than or equal to x is greater than -4, but it's nicer to see it in numerical order. So I always switch it in numerical order. Most common mistake I saw while you were working was in 17 actually. 1, not remembering that this negative goes with the 2. So you were multiplying by a -2, so -2 times x, -2 times 2. But the most common mistake was acting like these were on the same side, or excuse me, on different sides of an inequality. So I saw some people subtracting 5 from here, and from the 10, and from the -4, and from the 25. These are on the same, in the same part of the inequality, so you have to combine like terms first. 5 minus 4 is 1, and then solve this compound inequality. So we had to combine like terms to get 1, so I subtracted 1 from everything. I divided by a -2, and since I was dividing by a -2, I had to switch the signs. It wasn't in numerical order anymore, so I reversed the entire inequality, remembering that if it's open to the x or open to the other number, it stays that way once I switch it. 18, the only thing I want to point out, it was a pretty easy problem as long as you didn't drop a negative. I want you to remember for your final answer to include that word or. If you just had this part and this part without that or in the middle, it would not be a compound inequality. It needs to have that or. Alright, and the very last part, writing an inequality from a statement, so graphing and writing. When I was helping people, I suggest you just do one thing at a time. X is at least -6, so I know I'm dealing with -6. If you don't know which way the arrow should go, choose a number. Is -8 at least -6? No. So I know that it needed to go this way. Is -6 at least -6? Yes. So it is going to be a closed circle. So I have that part of it. Now, x has to be at most 2. Is 3 at most 2? No, it's more than. Is 1 at most 2? Yes. So once I graphed this little part, I knew it was going this way. Is 2 at most 2? Yes, that makes a true statement. So I knew it was going to be closed circle. Once I had that part, I tend to just erase the little ones, the little arrows, and have one arrow connecting the two parts to show this is my solution. After I have that, the inequality itself is very simple because I know that x has to be between negative 6 and 2, and it has to be or equal to because the circles were closed. So I knew what inequality symbol to use. So again, with 20, x is more than 2. So I went to 2, and I know it has to be anything more than that. Is 2 more than 2? No, so I wasn't going to include it. I just had an open circle. But, so I did this part, and then, but is at most 10. So I went to my 10. I knew I was dealing with this one. Is 10 at most 10? Yes, so it's going to be closed. Is 11 at most 10? No, it's more than 10, so I knew that my arrow was going this way. So in the end, I had this inequality, and then I could see that my x, my solution, is any number between 2 and 10, and then I could go back to look to see if it's open. It would not be an or equal to. If it's closed, it would be an or equal to. Hope that helps. Let me know if you have any questions. Have a good weekend.